in the link state routing algorithm, we are going to study the Dijkstra algorithm. So in case of the Dijkstra algorithm, it says that network topology, uh, the network topology link cost known to all nodes. Okay, so topology and that the cost from a node to the all other nodes is going to be known, and that is going to be accomplished via the link state broadcast. So all the nodes are going to be have the same information, okay, about the topology and about the cost. So say it computes least cost paths from one node source to all other nodes. So that means here we are going to be consider a source node in a network layout, and we should need to be find out from that source node to all other nodes available in the network. That means all other nodes are going to be our destination, and we are going to be uh, discover the least cost paths from source to every other nodes that are available in the network. All right. So now here say that gives forwarding table for that node. Okay, and iterative after k iterations, no least cost path from path to the k destinations. So here on, forget about this, the left part, come to the right part. This is the most important part that we need to understand. If you understand that, then it's going to be easy to understand that how the Dijkstra algorithm is going to be work for finding the least cost path from source to all other available nodes in the network. So here the cost of x to y, this is the link cost from node x to y, and if that the node y is not that the direct neighbors, then we are going to be use that infinity sign. That means it's unknown. Okay, so if it is happening like that, okay, this is that nodes. So these are the two nodes are directly connected, but this node is not the node y is not connected with x directly, so suggesting that, I mean, the y, so for the x, it doesn't know about that the y, so we are going to be using the table the infinity sign, that it's an unknown node for the node x. The dv means that the current value of cost of the path from source to destination v. So for example that the current path here, say that it is the 2 cost of x to w, and say that it is 1, say that it is 3, okay, and say that it is 1 1. So that means first of all, the x is going to be count these two nodes, the I and w. So if cost, the current cost is going to be from x to w is 3, but when uh, you are going to be, so you are going from x to w is 3 and x to I is 1, but when that it will go from I to w again, so the cost is 1 plus 1. So that means the later on the cost of the path from that a node to that another node, in this example x to w, it can be found the least cost path. So it's saying that, so what is the current value of cost path from the source to destination? So when it is moving from x to w, it is keeping the record that the cost of this path is 3. So this is going to be the current value, and later on that is going to be changed. So that is going to be the updated value, because with this path you have find out a least cost path compared with this the current value. So that means that is going to be updated in the table, that okay, least cost path is 2. We'll see that in the example, so don't worry. And it is here that the PV means that predecessor node along path from source to V. Yeah, so what is that the predecessor? You can think like it's a past node, previous node. Okay, so if you're considering that the first of all, when you start from x to w, so to come to the w, who is your previous node from the w? Who is your predecessor node from the w? It is x. Okay, so it is x, so that is going to be the PV. And when you actually update that the path from x I to w, On that time, who is going to be your previous node? I. Okay, so that is what that the PV is, that it is along with the path. So when it is keeping that in the table, the cost is 3, the predecessor node is X. So when it is going to be updated, that time it is going to be 2, the cost of path is going to be 2, 1 and 1. And on that time, the predecessor node is going to be I, something like that. Okay, and in here that in bar, that set of nodes whose least cost path is definitively known. Okay, so let's check that. I mean, it is going to be very clear in this example. So you can see that we are having a network layout graph. So here we have considered that as is the source. So we are having that total excluding the ace, we are having the 5 nodes. So that means we have to find the least cost path to from ace to all that the 5 nodes. All right, so now let's start it. So for each of the nodes is excluding that the u, because it's source, we are going to be start from here. So each of the nodes are going to be need to have that this dv and pv. Okay, because we are going to be found that dv and pv for each of the nodes from the source node. So we can see that, I mean, you are having the here x, w, v, y, z. So you can actually for each of the nodes you are having, that you can actually put it here in any combinations, in any order. Okay, not necessary that you should need to be right here v first, then w, then x, then y, then z. But it's better that you start with that the direct nodes, right? So that, I mean, where you can go directly. For example, here in this example, that you can see that from the u, you can go to the x directly. So the link, that is the link, black color, and then you can go come directly to u to w and u to v. So it's suggesting that these are the 3 direct nodes. So it's better that you write these 3 nodes at first. Okay, in any order. You can write wxv or xwv or vwx, whatever, in order. Any order you can actually write them. And then you are writing that the rest of the nodes, y and z. But if you are doing that, I mean, you are writing y and z first, and then you are writing them, then also no problem. Okay, let's start that. I mean, these are our direct nodes. Okay, so we are having that for each of the nodes, we are having the dv and pv, d and p, right? So that is here that d and p. Okay, so that here the node name is v, so it is dv and pv. We are having for w, dw and pw. We are having the x, the dx, px. We are having the y, dy, py, and we are having the z. We are having the d, z and pz. So from that. We want to start from u, so let's start from u. If we want to go from u to v, that my first node is v here, so I want to go from u to v, come to the graph. So you can see that u to v, if I'm coming u to v, then my cost is 7. So that I have written 7 for dv is 7 current value. And who is the predecessor now? That is the u, so comma u, pv is my u. Okay, I have written that as because I can go from u to v directly. So can I go u to w directly? Yes, I can go from u to w directly. So what is the cost? That is the 3. So I have written the 3, and this is my dw value is 3. And what is pw, predecessor node? That is u. So comma u I have written. And can we go u to x directly? U to x, yes, I can go u to x directly. What is the cost? My cost is 5. So I have written here the 5. Okay, so that u to x dx is my 5. So who is my predecessor node from x? That is the u. Okay, previous node is u, so predecessor node is u. So for p x, I have written comma u. So now, can I go u to y directly? Look that from u to y, I don't have any direct link. The y is not my direct neighbor. So that means I do not know that at this moment it is unknown that how to go to, how you can go from u to y. Then the next node is my Z. So can I go U to Z directly? No. It is also not a direct neighbor. I can do not have that the direct link. So that means it is also unknown. So now in this row, the zero step in this row, that the values you have found for that, for going from U to the different nodes, from these values, you should need to be find out who is the least cost. I mean, which number is the, minimum number out of this, the three values you have got in this row. So out of these three values, who is actually that, which one is that the having that the minimum number. So you can say the 7, 3, and 5. So I can see that my minimum number is 3. So that means I'm going to be take this path. Okay, I'm going to be take this path means that I'm going to be take the W for my next node, from where actually we'll continue the searching, list cost path searching. So that is why I'm taking the W. So you can see that next one with the U, I have added here W. So that means now we want to start from the W. So we have selected this node from this row number 1. We have selected the W. So from this node now we are going to start the search. So let's start it. So you have to understand one more thing here, that it is fixed. That means I have taken that U to W. If you want to go, then this is my list cost path 3. So I cannot get less than or least cost path than this, because I have taken this uh, granted it as my next node. So that means that path has already defined. So that means U to W path is now found already. That is the cost of 3, and predecessor node is U. So we have selected the W, the node, as in from here now we are going to start the list searching for the least cost path to the all other 4 nodes. So now you can start from W to V. Can you go from W to V? Yes. What is the cost? 3. And the value, the W we have selected from U to W you want to go, the value you selected 3. So here that the 3, that the value you're having, that must need to be added with this the link cost between that the U to W to V. Okay, so as because we are searching from W, so that means to come to the W from U, the cost is 3. So that the 3 must need to be added with the
স্যার
other. Yeah, exactly. Yeah, please carry on.
স্যার স্যার এই যে নাম্বার ওয়ানে যে ইউ এবং ডাব্লিউ ওইটা স্যার একটু রিপিট করবেন, এই যে নাম্বার ওয়ানে ওইটা কেন দিচ্ছে স্যার, ইউ আর ডাব্লিউ দুইটা একসাথে কেন?
Yeah, so this is what I'm saying here on that, from this row, that the values you have find, you should need to be checked who is having that the minimum value. The here you are having 7, 3, 5. So who is the
So
minimum
three
value?
is minimum.
3 is minimum, right? So
Yes,
that
sir.
the 3 is we are taking. So if the 3 you are taking, it belongs to which node? W.
Yes, sir. W.
So that's why you have taken the W as a next node, from where actually you'll start the restart the searching. Okay. So it is fixed. Already you have taken U to W, the cost is 3. So this is going to be the minimum cost. Okay, it's done. For the W, we are not going to be search anymore. So from the W, we are going to be start for the next other nodes list cost path. We are going to be search. So as because you have selected W, look that you have selected W and that your predecessor node is U. So what is the cost that you need to come to the W3? So if you're going from the W to any other nodes, so that the link cost of those links is going to be add with that the 3, because you have to come from W to X or W to V you want to go, you have to come U to W and then to them. So that means the cost is need to be add.
Sir, can you please repeat it, sir? I didn't understand.
Yeah, so what we are saying is that we have taken the W as granted, right? That I mean we have found that the least cost path between the U to W, that is the 3, cost of 3. Now we have taken that the W for that for the searching the least cost path to the all other available nodes. So now if you're starting for W, so that you want to go W to V, so you want to go W to V, so what is the link cost? 3. And with that 3, you must need to be add the 3. Why you
We
have to
have
add the
to
3?
add the previous one.
Right, exactly. So you have to add the 3 here. So that means it is going to be 3 plus 3. It is going to be 6. Do you understand that or not?
Yes, sir. Yes, sir. I understand.
Right, right. So now if you're coming to that W2 V, then it is coming 3 plus 3. 3 you are having here, and the link cost is 3. So that means 3 plus 3, it is 6. So if
Yes,
it
sir.
is 6,
6.
you did that the, I mean, less than that the value you're having here. That earlier you have found U to V is 7, and now you got
Yes, sir.
right. So that means it is least cost, right? Compare with that the previous value, the current value we are having in the table. Now that the new path is giving me the cost of 6, so it's suggesting that it is the least cost compared with that the previous one, isn't it or not?
Yes,
So
sir.
that means this is actually updating. That's why we are writing here 6. And now if I'm taking that the this link, that W2V, then who is my predecessor? I'm coming to the V, so my predecessor node is W. Okay, so that is
Yes,
why
sir.
I'm writing that 6W. Is it clear or not?
Yes, sir. It is clear.
All right. So
But
now
in
you can,
sir, step 1, we are also writing 5U and 11W. It's not
yeah,
clear.
we'll go there. We'll go there. Is it clear for W2V or not?
Yes, sir. It's clear.
Right. Now we are going to be moved from W to X. This one is already done. As I said, this one is already done. So we are going to be moved from W to X. Is there any direct link from W to X? Yes. We are having a
Yes,
direct
sir.
link.
4. And
Yeah,
previously
because
we
The
have
phone
6.
number path.
It
so
can be 10.
it is 4. No, 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 no. It's not going to be
7.
10. It's going to be 4 and 3. 4 plus 3.
7.
Right?
Yes.
Do you understand that or not? It's going to be
Yes,
4.
sir.
We are coming U to W and W to X. So it's going to be 3 plus 4. It is
4.
going to be 7. Understand or not?
Yes, sir. Now it's clear.
Okay. So what was your previous value? 5,
5.
right? So
Yes.
7 is greater than 5. So that means we are not going to be change, update the table value, right? It is going to be as it is. Understand or not?
Yes, sir.
Yeah, right. So now if you're going from the W to Y, do you have any link? Yes, you're having a link W to Y. So what is the cost? 8. So
8.
8
And previously
plus
we have
3.
3.
Right.
And
So
it's
8 plus
11.
3, 11, right? So this is what we are writing 11. So you
Yes.
want to come to Y. So from where you are coming to Y? From W. So your W is your predecessor node. Understand or not?
Yes,
So
sir.
Y is W. Clear?
Yes, sir. Clear.
So from W to Z, can you go from W to Z directly? No. So it was unknown and still it is unknown. Okay. Now from this row, you have to find again that what is the minimum value. Which node is having that the minimum value? So we can see that is 5.
Yes, sir. It's 5.
Right? 6, 5 elements. So 5 is my minimum value. So the next node I am going to be. So this is 6, that how to go to the X, for you to X. Okay. And now I want to take that the X. I have selected the X as a next node. Okay. From the X, we are going to be continue the searching to the other nodes. Now you coming to that the X node. So if can you go, so where is that X? It is that the X, right? So you're going to be start from the X now. So if I'm starting from the X, then from the X, can I go to the V directly? No, there is no link, direct link from the X. This is my X and this is my V. So there is no direct link, okay, from between that the X and V. So that means I kept the value as it is, right? So I had the 6W, I'm keeping it as it is. So now I'm going to be moved from X to Y, okay? Can I go from the X to Y directly? Yes. What is the cost? 7. Okay, what is in my hand? That is my 5, right? This is the 5 I'm having here. This is my 5. Okay, so 7 plus 5, how much it is coming?
12.
12. What is the current value? 11. So that
11.
means it is not going to be updated, okay? Because this 12 is larger than 11, right?
Yes, sir.
Greater than 11. So that we are keeping that as it is, 11W as it is. Can I go from X to Z directly? Yes, I can go X to Z directly. What is the cost? 9. And what is in my hand? 5. So
5.
9
It's
plus
14,
5.
sir.
It is going to be 14. So that you can say that I have written here 14. The DZ is actually 14. And from that the j from to j from where we come, that x. So x is my predecessor node, the pz is actually my x node. Clear?
Yes, sir.
Yeah, right. So now in this row, again I have to check that the minimum value. So I am having 6, 11, 14. So out of these values, 6 is my minimum value here, so I'm going to be take this now. All right. So if I'm taking this now, then which node it belongs to? Node V. So that means node V I'm going to be take as my next node. Okay. So this search is going to be continued until we get the least cost path for every other nodes. Okay. So now I have taken that the V node, this one, I have taken the 6 here from this row. So V, from V will start. In my hand, how much I'm having? 6. Remember that. So from V, can we go to the V to Y directly? These are already found. The V,
Yes, sir. We can go from
VW.
V to Y.
Right. So V to Y. Can we go directly V to Y? Yes. So what is the cost? 4. And what
4.
is in my hand? 6.
6.
Right?
It will be 10, sir. Now it
So
will
it is
be
coming 10. So what was that the previous value? 11. So 10 is the smaller than 11. So that means it is going to be updated. So my dy is 10. And from V actually we come to, sorry, from where we come? Yes, from V we go to the Y. So that the predecessor node is going to be my V, right?
yes, sir.
So that the py is my V here. So now can I go from V to Z directly? V is here, Z is here. No, there
No,
is no
sir.
direct link is there. So Z is not the direct neighbor of V. So that means the value we found earlier, we kept that as it is. So now out of these two, this is my minimum value 10 and 14. So that means we are going to be take the Y as the next node, or from we are going to be search the path to other nodes. So if I'm taking Y, so what is in my hand? That is the 10. From Y to Z, can I go Y to Z directly? Yes. What is the cost? 2. And what is in my hand? 10. 10 plus 2, it is 12.
12.
What was my previous value? 14. So that means 12 is smaller than 14. So
We are
so
updating
it is
it.
going to be updated. Right. It's going to be updated. So that I'm writing the 12 as a DZ. And from where I came to Z? From Y. So that Y is my PZ. Okay. So in this row, we are having the only one value, so we are going to be take the Z, right? So that's how we have finished all that the nodes available in that the graph. Clear?
Yes, sir. Clear.
How about the others are not talking. Hello,
Yes, sir.
Yes, sir. Yes, sir.
do you understand it?
Yes,
Yes,
sir.
sir.
Yes,
Yes,
sir.
sir.
Yeah, so I mean these are the algorithms are very important for your midterm examination, right? So one problem definitely will come from this two algorithms. Okay, so you should need to be practice these algorithms that we are routing algorithms that we have discussed in the class. Yeah, Ridoy, you have a question, I guess. Fuadul Islam Ridoy. Okay. Yeah, I can hear you. Okay, okay, that's great. Okay, thank you. So now we have found that, I mean, we have learned it that how it is going to be done. But here one line is say that construct shortest path tree by tracing the predecessor nodes and ties can exit. Okay, so it can happen that in a row that the values we are getting, it can be happen the values are going to be ties. Ties means what? Say that for V it is coming 7, 7u, and here also say that it's coming 7, okay, and say that it is coming 8. So look that among these three values, 7, 7, 8, if it is coming like that, so now these are the two values are same. I mean, these are the least minimum value, but we have got the ties. Means that these two values. So which one is going to be taken? Okay, so that is what is saying that ties can exist. If it is existing, that which value is going to be taken. So you can actually take any one of them, one after another. Actually you can take, there is not going to be any problem. For that we are having an example here. Okay, so here you can see that we are having the source here, the u, and from u we would like to find out the least cost path to every other nodes. So you can see that we are having the 5 nodes here, that v w x y z. So we are writing v w x y z. So now for each of the nodes we are going to be have d and p. So dv pv for v nodes. For w it is dw pw. For x it is dx px. For y it is dy py. And for z it is dz pz. So we are going to start from u, as because this is my source node. So if you're starting from the source node, if can I go u to v directly? Yes, I can go u to v directly. So what is the cost? My cost is 2. So I have written 2 for dv. And what is my predecessor node? For coming to the v, from where I came, from u. So that the predecessor node is my u. So pv is u. Can I go u to w directly? Yes, I can go u to w directly. What is the cost? 5. So that the 5 I have written for dw. And what is the pw? Where from actually you came to w? From u. So that u is your predecessor node. Now, can you go to that u to x directly? Yes, you can go. What is the cost? 1. So that u1 you are writing. So to x, where from you came? You came from u. So your predecessor node is u that you have updated. Can you go from u to y directly? No, there is no direct link. So y is not the direct neighbor of u. So that is unknown to us at this moment. Can I go from U to Z directly? No, there is no direct link of that the U to between the U and Z. So Z is actually not direct neighbor of the U. So I can keep it as a unknown. Now, out of these values, you can see that you got 2, 5, and 1. So definitely that 1 is that the minimum value. So that the next node you are going to be take, that is the X. So now this is the node you selected X. So what is in your hand? 1. The value 1 here, right? So from x to v, can you go to the x to v directly? Yes. What is the value? 2. And what is in your hand? 1. 2 plus 1, 3. What was your previous find value? 2. So that means it is larger than the previous value. So we are not changing. We are keeping it as it is 2u. Now, can you go to the x to w directly? X to w directly? Yes, I can go. What is the cost? 3. What you are having in my hand? 1. 3 plus 1, it is 4. What was that the previous value? 5. So that, I mean, we can find that the 4 actually less than the 5. So that means it is going to be updated. The new value we have got 4. So we have written the 4 for dw. So what is my predecessor node? Or from I started, where I'm coming? X to w. So x to w. So where from I came to w? From x. So that x is my pw here. So now can I go from x to y directly? X to y directly. Yes, I can go. That is the value is 1. And what is in my hand? 1. So 1 plus 1 equals 2. That it was unknown. So I am updating it with that the 2. And if I want to come to y from x, so x is my predecessor node. So I have written the x here. And can I go x to z directly? X to z? No. There is no direct connections between the x and z. So it is unknown. It was unknown and now also it is unknown. So now see that here we are having the ties. So out of this three value, 2, 4, 2. So minimum value is 2. So which one you are going to be take? So you can take any one of them, no problem. You can take this one, you can take this one. Okay, so here in this example we have taken this one, so that means y has been taken here as a next node. So from y, if you're starting, what is in your hand? 2. Remember that this is the value you have to keep in your hand. So from y you are starting from y to v. Can you go directly? No, there is no direct link between the v and y. So that the value we have kept as it is, the 2u. Now, can I go from y to w directly? Y to w, yes, I can go. What is that the value in my hand? 2. And what is here the value for going to from y to w? 1. So 2 plus 1, it is going to be 3. What is my previous value? 4. So I can see that list cost, I mean, I have found here. So 3 I have updated. And so dw is my now 3. And what is the pw? So you're coming from y to w, right? So y is your y to w. So y is your previous node, predecessor node. So you have updated your pw is going to be y. All right, so can we go from y to z directly? Yes, we can go y to z directly. What is the cost here? 2. And what is in your hand? 2. 2 plus 2, 4. That actually you have updated. It was unknown, so now you found a path with the cost 4. So you want to come from y to z. So y to z. So who was your previous node? Y. So that is that the y you have kept as a predecessor node, pz. So now out of these three values, which one is the least minimum value? This one, 2. So you're going to be take that the v as a next node. So how much you
স্যার
need? Yeah.
স্যার আমরা কেন ওয়াই থেকে এক্স নোটে আমরা কাউন্ট করলাম না, ওটাকে কেন আমরা কনসিডার করে বাদ রাখলাম স্যার এক্ষেত্রে?
X, because we have already I mean taken it, granted it, and that this is going to be the least cost path, right? We have already taken this note, that's why I did not consider X. Okay,
Yes, sir.
understand? Then we have now we have taken that the y. So now from that the y we are starting, we are not going to y. Why? Because it is already granted. Understand or not? Clear?
Yes, sir.
Okay.
Sir,
Now
sir, in step 2, you said that uh, um, in step 1 to 2, you take dy and py, that's mean 2x. Sir, x থেকে v তে যাওয়া যায় না, তাহলে স্যার আগের গুলোতে তো আমরা ইনফিনিট ইউজ করছি, তাহলে এখানে কেন আগের ভ্যালুটাই দিয়েছি আমরা?
what is the value you are having in your hand, right? So
Yes, sir.
that should keep with you. Okay, what you are doing is that you have got a path to go to a node and you know the cost, right? So you are keeping it with you.
Yes, sir.
If you are getting any least cost path later on, then only this is going to be updated. But if you're not getting any
Yes, sir.
least cost path, that what you have in your hand, that is going to be actually taken later on as a least cost path. Understand?
Okay. Yes, sir. Yes, sir. Understand, sir.
Yeah. So now you have taken the v, right? So if you're starting from v, what is the value you are having in your hand? 2. Okay, so you're starting from v, so this is done. So v to w, can you go to the v to w direct? Yes. What is
Yes,
the
sir.
cost?
It's 3, sir.
And what is in your hand? 2.
2,
2 plus 2 equals 5. What was that the previous value you are having? 3.
3.
So that
So we are writing as it is.
right. So that we are adding 3 and y as it is. Okay, there is no change. So now can I go from v to z directly? That v to z, no, there is no direct link between the v to z, between the v and z. There is no direct link. So that means we are going to be keep what we had before, the 4y. So it is 4y. All right. So
Yes, sir.
now between these two, in this row we are having the 3y and 4y. So this is my minimum value. Okay, 3. So that means we are going to be take that the w as a next node. Okay, so from the w we're going to be search. So from the w, can you go to the z? So what is the value we are having in the hand? 3. So
3 and
from w to z, can you go directly w to z? Yes. What is
yes,
the
sir. So
5?
it's 5.
And in our hand it is 3. So 5 plus 3, it is 8, right? What was my previous value? That was 4. So
4.
that means it is not going to be updated, as because it is
Yes.
larger than the previous,
We're
right?
writing it as it is.
Right, we are keeping it as it is. So it is that the only value we are having. So that means the last node we are counting here. Okay, so that is the, end of searching the least cost path from U to every other nodes. Is it clear?
Yes, sir, it's clear. Sir, you told we have learned two algorithm, but here I can see we have learned one. Sir, which one is another?
So this is the link state routing protocol, right? So it is the Dijkstra algorithm. And here we are studying that the distance vector routing algorithm, right? So the
Yes, sir.
Bellman-Ford algorithm, right?
Yes, sir.
So these are the two algorithms, different algorithms. One is the distance vector, one is the link state. Understand?
Yes, sir.
Do you have any question in today's algorithm that we have discussed?
স্যার
No, sir.
Can you
Yeah.
please repeat the previous algorithm again?
স্যার নেটে অনেক
Mm,
সমস্যা করতেছে স্যার, মানে অনেক কিছু মিস করে গেছে স্যার।
yeah. So if you missed it, we have discussed the same algorithm with the two example. So I do not expect that. You missed out both of them. If you understand any one of them, that is going to be enough. If you are now,
Yes, sir. I
practicing
have
with your
understood
hand, then
clearly one.
right. You do not need to understand the both. If you understand one, then any other example it is given to you, you'll be able to easily do it.
Yes, sir.
So, is there any other persons have the any comments on this algorithm? That if there is something that you do not understand, yeah, it is. The graph most probably it is going to be given to you. If it is not, then maybe a scenario is going to be given to you with the cost. So maybe you need to draw that the graph by yourself. And also if it is asking to you that okay, you need to draw the graph by following that the scenario of the scenario of the question. If you're drawing it with correctly, you're drawing it, there is going to be some marks as well. Okay, for drawing also maybe there can be marks like 5 marks. So it is good if it is coming as a scenario based rather than the directly graph is given to you. But it can be happen that directly graph is given to you and you have to find it out the least cost path from the source to all the destination nodes, all other nodes actually.
স্যার আরেকটা যে অ্যালগরিদমের কথা বললেন স্যার, ওইটা কি আসার পসিবিলিটি নেই?
Yeah, I said that both of the algorithms you have to study properly, right? I said that one of the will come one of the question will come out of these two algorithms. Okay.
স্যার এই অ্যালগরিদমটা বুঝিনি।
No, that will come later on. I'll finish one by one. So Likuni, you understand?
Yes, sir.
Likuni, you are
Yes, sir.
having here the two algorithms. You have studied the Bellman-Ford algorithm. Okay, we have seen that this is the distance vector. From the distance vector algorithm, we have studied Bellman-Ford, and from that the link state, we have studied the Dijkstra algorithm. I say that you have to practice at your home both of these algorithms, and one of them will come in the exam, in the
Okay, sir.
midterm exam. Okay.
Okay, sir.
Yeah. Now that Mithi is asking to, repeat this algorithm. So, is there any other
Yes,
person
sir.
that need it? Look, that if you, do not under, if only it's Mithi, then I'll tell to Mithi that please come to that the consultation hour. If
Sir, I also
স্যার
I didn't know.
Sir, I
I
also
also
don't
100%
understand it.
understand.
স্যার আমাদের এটা করানো হয় নাই।
স্যার সবারই মোটামুটি প্রবলেম আছে স্যার এটাতে।
so, where is the problem in that? Can you tell me?
স্যার এই অ্যালগরিদম আমাদের পড়ানোই হয় না।
জি স্যার, এটা তো আমাদের করানো
স্যার, এটা
হয় নাই।
কবে করেছেন স্যার? এটাই তো স্যার
এটা তো আমাদের করানো হয় নাই।
স্যার এটা আমাদের পড়ানো হয় নাই।
ও এটা কি আমরা পড়াই নাই? তোমাদের ক্লাসে পড়ানো হয় না এটা?
নো স্যার,
No, sir, no,
পড়ানো হয় নাই আমাদের।
হয় নাই।
লাস্ট ক্লাসে তো রাউটিং প্রোটোকল
স্যার লাস্ট ক্লাসে আমাদের রাউটিং প্রোটোকল পড়ানো হয়েছে, এটা পড়ানো হয় নাই আমাদের। স্যার ইউনিকাস্ট রাউটিং প্রোটোকলটা পড়ানো হয়েছে, এগুলো ধরা হয় নাই স্যার।
জি স্যার, ইউনিকাস্ট অনলি পড়ানো হয়েছে, এগুলো আমাদের শুরু করা হয় নাই।
আমার নেটওয়ার্ক
স্যার
ক্লিয়ার আছে
একটাই
স্যার।
বলতেছিলাম।
So
আমার স্যার নেটওয়ার্ক
huh?
আমার স্যার
In the
নেটওয়ার্ক ক্লিয়ার আছে।
yeah, we are in the network layer. This is the network layer lecture only. But how much we have covered in the last class?
স্যার
This
স্যার
লাস্ট
is
ক্লাস 28 and 29 স্লাইড, এই দুইটা স্লাইড পড়াইছিলেন।
28 and 29. Oh,
ইয়েস
that means
স্যার।
স্যার এটা পড়ানো হয় নাই স্যার।
তুমি তো বলতেছো 28, 29.
স্যার জাস্ট ওই দুইটা স্লাইড পড়াইছিলেন, মানে এটা তো আমাদের নতুন লেকচার শুরু করেছিলেন, এর জন্য এই দুইটা পড়ানো হয়েছিল।
So did we
মানে
talk
স্যার
about the Bellman-Ford equation?
নো স্যার।
নো
No
স্যার,
স্যার,
এইটাও পড়ানো হয় নাই।
হয়নি।
Did you study this slide?
স্যার আপনি স্যার ওই প্রথমে কয়েকটা স্লাইড স্কিপ করে গেছিলেন এবং
স্যার
ডাইরেক্ট
এই
স্যার
স্লাইড গুলো সব স্কিপ করে চলে গেছিলেন।
No. Definitely we have started from here.
Sir, in the last class, route discovery, RRFQ, RRFD, RERR, এগুলো স্যার ডিসকাস করা হয়েছে।
That means we are discussing in the last class about that the interdomain routing and interdomain
Yes, sir,
routing.
just theoretical part.
ইয়েস স্যার ইয়েস স্যার।
routing স্যার।
Okay. So that the things we are discussing, that I mean in the internet we are having the different autonomous system, right? So in the class I can remember now that what we are discussing in the classroom physically. So we are talking about that in the autonomous system there can be the many routers, okay, that the the network inside the autonomous system, the network can be very complex or it can be also a very simple one. So whatever it is in the autonomous system, we are going to be use the interdomain routing protocol. And the interdomain routing protocol in the inside the autonomous system, the interdomain routing protocol, we are having the several protocols like we are having the REAP, we are having the OSPF. Okay, so inside that the autonomous system, we can use I mean any routing protocol, as well as it can be possible that you will be able to use more than one routing protocol. It has been maybe said here also. In case of interdomain routing protocols to handle routing inside the autonomous system, however, only one. Yes, it said that each autonomous system can choose one or more interdomain routing protocols to handle routing inside the autonomous system, right? So that is the interdomain routing. It's possible that you'll be able to use more than one routing protocol if the network is complex. If you want to divide the network from one part to the another inside of the autonomous system, on that time you can use multiple interdomain routing protocol, or you can use only single one, no problem on there. It's up to you, you're going to be decided. But for making the connections between the autonomous systems, okay, we are going to be use the interdomain routing. And in case of interdomain routing, we are only using single routing protocol, and that is the BGP. Okay, so if we are using the internet, means that we are actually using the BGP, that is the interdomain part. And intradomain, we are having the distance vector and the link state. So the distance vector routing algorithm are like that the REAP, and link state routing algorithm like that the OSPF. So there is the another routing protocol here like EIGRP is the distance vector routing protocol. So anyway, so there are different types of protocols are there. So in case of in this lecture that we are studying, actually the from the distance vector we are studying the Bellman-Ford equation, Bellman-Ford algorithm. So that is actually used by REAP. And then the link state routing protocol, we are going to be study that the Dijkstra algorithm that is used by that the OSPF. Okay, so this is that the to understand that the routing, we should need to be understand the graph abstraction. So we know that a graph is actually consist of V and E, vertex and edges. So here we are considering that G equals N and E. So that N here is the set of routers in the graph. So this is a graph example, the figure number 12. So here that the router you are having that U, V, X, W, Y, Z. So these are your routers, and these are going to be considered as N. So it is, you can see that from this graph you are having the U, V, W, X, Y, Z, U, V, W, X, Y, Z. So these are the routers are available in that the graph. and that E means that the set of links, so edges, right? So that is that connections between that the two nodes, right? So like U to V, like U to X, like V to X, like U to W, W to Y, X to W, W to Z, Y to Z. So these are all that the links are actually considered as E. So it's saying that graph abstraction cost. So if you're going from say that cost of a source to that the destination, so this is going to be actually cost of link that you are having a source to the destination. So for example, you are having the cost of W to Z. It is showing the W to Z, right? So the cost has been given here as a 5. Cost could be always be 1 or inversely related to bandwidth, inversely related to congregation. So the cost can be actually the cost will come with that the different matrix. It can be hop, it can be bandwidth, it can be delay. Okay, so it's saying that what is the least cost path between U and Z. So in this graph, so if it is asking to you that what is the least cost path between them, then the algorithm that find that the least cost path. Okay, so we have to use actually routing algorithm to find that the least cost path between the U and Z. Okay, so these are the facts. It's already, I mean, I have discussed. So here, the shortest path algorithm. Yeah, so the shortest path algorithm means what? It's saying that the shortest path is the path with the least cost. Okay, so the sum of the cost of the links on the path is minimum overall possible paths between the source and destination. So you are having a say that here you are having the two paths between the source and destination. It is your source, it is your destination. So it is telling that it is going to be find out with the shortest path algorithm will be able to find out that what is going to be the least cost path between these two. So if it is, I mean, by seeing this graph, human can itself calculate that, okay, this is going to be the least cost path because the cost is going to be 1 plus 1 equals 2. But here the path cost is 5. So this is actually not the least cost path. This is going to be the least cost path. So it's saying that the shortest path is the path with the least cost. So which path is going to be the least cost? If there are many paths you are having for going from S to the D, then out of those paths, what is going to be the least cost path? Okay, that is going to be find out by the shortest path algorithm. So the two main algorithms to find the shortest path between any two nodes. So the distance vector, I said that Bellman-Ford algorithm we are going to be discuss. Link state routing protocol, that is the digest algorithm already that we have started with the class today. So digest algorithm we have done. So let's start with the distance vector algorithm. So in case of the distance vector algorithm, the Bellman-Ford algorithm, that, I mean, you should need to be understand this equation. So if you understand this equation, the things are going to be easy to understand. So that here it's saying that the x to y, so that the x is actually your source and y is actually your destination. So say that cost of least cost path from x to y. Okay, so that the equation is going to be this one. So the cost of dx to y, so from that means from source to destination, if you want to find that the least cost path, then the formula is this one. What is that? Mean v, minimum take mean taken over all neighbors v of x. So and here this is the main thing, that what you are having the cost of x to v and plus dv to y. So say that there is an like that, so that this is a graph. And here, so the cost of x to v, so x is my source and say that d is my destination. Okay, so that means here the cost of x to v, so if I'm considering that is v, I'm also giving the name that of the node v. So what is the cost here? That is 3. Okay, so now what is the cost here? 2. So now plus it said that dv to y, so that is my dv. This is the node, that is my v. Okay, dv to y, so dv to y, who is y here? My destination. Who is my destination? D. So that means dv to y is going to be 2. So that means the cost of path is going to be 5. All right, so here another thing is coming, that it can happen. So from that the node, so say that this is my source and say that there are two nodes we are having. that are directly connected with A and B. A and B. Okay. So now from this node you are going to C. From this node you are going to D, and from this node you are going to E. That is your actually destination. Okay, this is your destination. So now look that we can see here that there are two paths for from going from that the source A to that the destination E. Okay, so now that means we are going to be apply this equation for the both of the paths to find out that what is going to be the least cost of path. So that these are the cost. So now look that this is telling that cost of x to v. So x to so here the v we are having the two paths, so that means two direct nodes are there, direct neighbors are there. I am having one is A and one is B. Okay, so that A and B, so this is going to be, if I want to find a path, that is going to be cost of A to V. That means if I'm considering S to A, so this is going to be S to A, cost of S to A, and with that I have to make dv to y. So in this case this is my v, right? So A, that is going to be dA, and who is going to be my destination E, so that is going to be my E. This is going to be formula for this the first path, and for the second path it is going to be cost of this is my S and this is my B, so cost of S to B and plus dv to E. Do you understand this two formula based on this?
Can you
No,
repeat?
sir, no, sir, not clear, sir.
Not clear. Not clear. So this is what I think that it's better you come to this algorithm, this example directly, because I am my writing is not good. Maybe because of that you're not understanding. So here, look that this is my U is my source, and this is my destination U to Z. Okay, so I want to find the least cost path between U to Z. So you can see that who are the direct node from that the U. The W, because I can go directly here, cost is 5, and I can go directly from U to X, that is the cost
Sir,
U. I can, yeah,
sir, why we are considering U to W? We can
yeah, you
consider
can
U
see
to
that there
X.
is a link. You can see that there is a link, direct link.
Oh, yeah.
There is a direct link, right?
Yes,
So
sir.
that is the 5, and U to V, that is also directly connected, and U to X. So there are three direct nodes. W is not, sorry, Y is not directly connected with you, and Z is not directly connected with you. So who is your direct neighbors from the source? That is the W, X, and V. So that means I can understand that there can be the three, minimum three paths, okay, from going
Yes.
from U to Z through that the three direct neighbors. So I have to find out that with the Bellman-Ford equation, I have to find out that which out of these three paths, which is going to be my least cost path. All right, so look at what is the factor is that the direct node cost we already know. We know that from U to W, if I'm going, that is the cost of 5. So that the first part, that CX to V, that is cost of source to that the direct node. Okay, that we know that for each of them the cost, that U to W is 5, U to V is 2, U to X is 1. So now from this node, the direct node I am having, that means W, X, and X and V. From these three nodes, we should need to be find out the least cost path to the destination. So if you're starting, for example, from V, from this node, look that there are several paths we are having for going to the Z. This is one path, cost is 8. This is one path, cost is 5. This is the another path, 5, 6, 8. This is the another path, 2, 3, 5, 8, 10. 2, 3, 5, 10. This is the another path, 3 plus 5, that is the 8. So we it is going to find out that what is the least cost path between the F and V and Z. That is going to be my dvz. Okay, it is showing dvy because y it has been considered as the destination, right? So it is going to be dvz. So I know that this is the path among all the paths.
So here our destination is Z.
Z, right? Here is my destination is Z. So that is my list of path. It has been found. That is actually 5. 2 plus 1 plus 2. So that's what we have writing here. dvz equals 5. So now, if you want to go for the next neighbor node, say that x. So if you want to go from the x, there are several paths again. X, V, W, Z, that is 5 plus 5, 10. X, W, Z, that is 3 plus 5, 8. X, W, Y, Z, that is 4 plus 2, 6. And then if you're going to X, Y, Z, that is 3. So the 3 is the least cost path. So that means dx to z is my 3.
So we
And
are considering the least one.
yes, least cost one, right? So now the last direct node was my W. So from the W you can check W to Z, it is the 5 cost. W, Y, Z, that is the 3. So 3 is that the least cost path for DWZ. So what we have done, we have actually from the direct node to the destination, we have find out that what is the least cost from going from the direct node to the destination. Okay, that we have found for this part of the equation, dvy. So now if you are applying that the equation, so you can see that minimum cost of u to v, so that is your u to v and dv to z. Okay, so from your direct
Sir,
node to destination. Yeah.
স্যার ডিভিজেড ডিএক্সজেড এটা আরেকবার বলবেন স্যার প্লিজ।
All right. So that I mean, the formula is telling to us that from the source node to the direct node you're going, that is the cost of x to v. Okay, for a path. Do you understand that?
ইয়েস ইয়েস স্যার।
And the second part is telling that from this node, so if it is my say that v, so this is telling that say that similar with that equation cost x to v, so that is actually that the value you have given here, the 2. Now from the v to y, there can be the several paths it can come to that the y, right?
ইয়েস স্যার।
So now from this node you're going to be find out that which path cost is going to be minimum. That is actually dv to y. So if it is coming that here 1 plus 2 1 1, then 2 2, so which one is least cost? This one, right? So that means your
ইয়েস
dvy
স্যার।
here is what? 2. Understand?
ইয়েস স্যার।
So from the direct node, that the 3 nodes direct node, from the direct node actually you are finding first that what is your least cost path. Okay, so when you are having this value, you already know that what is the direct node cost from the source. So you can just add them, simply you can just add them to find out the cost of the paths. So you can see that du to z, if you want to go, you are having 3 paths. So it is considering minimum cu to v, so that is a cu to v. And from v to z, what is that the least cost path you have found already? That is 5. So that is
5
actually your 2 plus 5. The 2 is for cost of u to v. Cost of u to v is your 2, and you are found it that dvz is actually your 5. So 2 plus 5. Okay. Then another path is telling the cost of u to x. Your cost is 1. U to x, that is the 1. And cost of dx to z. So from x to z, what is the least cost path? That actually you have found here. Dx to z is 3. So that means 1 plus 3. You understand that for this formula? Cost of u to x is 1 and cost of dx to z is 3. So 1 plus 3. And next path, that is cost of u to w. Cost of u to w plus dw to z. What is the least cost path you have found? That is 3. So that means cost of u to w is 5. So 5 and plus 3. 3. So now if you're counting it, you're getting 7. You are getting 4 here and you are getting 8 here. Right? So out of these, which one is least cost? This one. So
4.
that's why the
That's
least
why
cost.
we are writing 4.
Right. Clear?
Yes, sir.
Okay,
Yes.
so I think you can practice this at your home. Okay, so you need to be practice. You need to be actually understand this equation properly. If you understand this equation properly, then you are going to be easily understand the next example here. Okay. Otherwise it is going to be difficult to understand this one.